everyone. You know, it's not fair after this performance. Sadly, I cannot play harp, but I can play security. So, a little bit about the background. My name is Omar. I'm CEO of Security, and my whole life I was hacking stuff, mostly Web2 stuff. I was doing penetration testing of various infrastructures and security reviews of the applications, mainly web applications. And in security, most of us come from the same background. So we've been doing a lot of penetration tests and application security, and then pivoted and switched to Web3. So our main business is security reviews for the smart contracts and other types of blockchain applications, including these Web 2.5 applications. And we also developed our threat detection tool called DeFi-Mon, which is on-chain hack detection product. And apart from the business side, we also have a bunch of community tools that you should be using. So first is Contract Diff. It's a website where you can check a contract against a database of various protocol code bases, and the tool will highlight which protocols has this contract been forked from using the fuzzy matching. So it's not the exact matching and diff, but it's fuzzy diff, so it's quite useful. And the other notable tool is SendGrep, which is open source tool. It's not our product, but we developed and we are maintaining the public the public rule pack for Solidity that covers many different DeFi exploits that happened in the past. So, Web 2.5, what is it? Let's start from Web 2. Right? I think everyone here has more or less the same understanding about what is Web 2. Most of us think of Web 2 as about centralized applications. That is, applications that run on a single machine or on a distributed infrastructure, but it's not based on consensus. Whereas Web 3 is the decentralized world, and here the applications run on multiple parties, and there is a consensus algorithm. So these are the blockchain nodes, the relayers, the smart contracts, and such. So what I call Web 2.5 is essentially Web 2, which is connected to Web 3. So those are Web 2 applications that process data from the blockchain, from DOT, and send data there. So there is a two-way integration. What consequences does this integration have on the security of such applications? Well, first of all, Web 2.5 technically is Web 2. So everything applicable to normal applications and infrastructures in Web 2 is also applicable to these Web 2.5 systems. But there is also this integration part, and to be able to test it, you have to understand both worlds. You have to understand what kind of vulnerabilities exist in the web applications and client-side apps, and what kind of interactions and attacks can you do in the blockchain. So what this means is that the attack surface becomes much bigger and more diverse. You have to know more types of technologies to review the security of Web 2.5 systems. So if we take a bird view at the data flow diagram of a typical Web 2.5 system, there will be this Web 2 part, which can be a centralized exchange, it can be a wallet, anything really. There are users who possibly have their own keys, so they interact with the RPC nodes to do transactions on chain. And this Web 2 product is also interacting with RPC nodes to get this data and to send transactions. And there are also some third-party APIs, such as oracles that provide the token prices, for example, or anything like that. And there is, of course, blockchain, which is kind of backhand behind all these services. Now, what are the untrusted user inputs in the Web2 systems? There are lots of them, but if we go from the bottom up, from the low level of network module, we see that, for example, even IP address is actually an input. Then there can be some SSL certificate fields and DNS records and such. And of course, the main thing is happening on the upper level in the HTTP or any other protocol which is used. Headers, HTTP parameters, WebSocket packets, and also, of course, the third parties, the other APIs and other microservices, even databases are also untrusted input in some way. So what about Web 2.5? Well, actually, Web 2.5 is exactly the same, because it's all the same, but these third parties that I'm talking about are a little bit different. So Web 2.5 untrusted inputs are all the same, plus, well, the main type of an external API for the Web 2.5 application is RPC node, of course. And there is also transaction data, which is processed in different ways. So this is one more serialization format for these types of applications. And there can be, of course, other types of external dependencies. So here I want to become more practical and talk about some concrete ideas, what you can check when you are reviewing the security of such systems. This is not a complete methodology. This is just a bunch of random thoughts and points that we noted during our penetration tests. So if you are pen testing the on-ramp component of any system, which is the component that accepts crypto payments, basically, then you should test for a few test cases, including the partial payments. You initialize a payment for 100 USD, and the application thinks that you're going to pay 100 USD, and then it doesn't check the amount that you sent. It only checks that there is a successful transaction with a positive value, and then it just debits this, credits this amount to your account. There can be errors with the internal transaction processing. You can create a smart contract that sends ETH to the target address of this on-ramp solution and then reverts. And if this solution parses these internal transactions and does not check that they have been reverted, then it can also credit this amount to you. So that there can be some also theoretical scenarios like creating a fake token, and maybe they don't just analyze all the events emitted by the, for example, USDT smart contract, but maybe they are monitoring the balance of the account they created for you. Maybe the fake tokens might work. So this is worth checking anyway, especially when you're doing black box testing. So you don't exactly know how it works on the server side. And of course, you should always be checking the number of confirmations on each chain which is required to deposit the money. So for example, on Bitcoin, you can do replace by fee transactions and just overwrite the receiver of the funds. On the off-ramp side, which is the component that withdraws money from this Web 2.5 system to your account, there are less potential attack vectors, but at least you can check for the gas griefing. You can create a smart contract with a fallback that reverts, and then each time you try to withdraw funds to that address, it will revert. You'll still have this balance on your centralized exchange account, but they will spend money on the gas. So this way you can just destroy their balance. The double spending is also possible because usually they withdraw the amount from some hot wallet that contains funds of different users, not just you. So this wallet has more money than you have in your account. So potentially, if there is a race condition in their centralized part, the double spending could be possible. Now, both on and off-ramp components usually rely on the single component called custody. So each centralized custodial system has the custody component, which is a component that generates the wallets for each user, individual wallets where you can send the money. It generates the private keys, of course, for those addresses, and manage all the transfers and interactions. So in these custodies, there might be many different bugs, starting from the cryptographic vulnerabilities in the way they create these private keys and addresses, in the way they create the transactions. Well, for example, there is a bug which is present in all the capture the flag war games, where if the nonce is reused in a transaction, you can recreate the private key. I haven't seen it in the real systems, but anyway, you can check it. So also there can be some common misconfigurations. Of course, they could expose their node with the private keys, and if they're unlocked, then they are damned. And I think the single most common vulnerability on the business logic level of every web application is insecure direct object reference. And it is also common in the custodial solutions, which means that you use your own account session and you reference the other user's identifier to try to withdraw funds from their account. And it might work, and it often works. Also, if this custody is implemented as a separate service, then the client service, which is, for example, centralized exchange that manages all the user registrations and such, they might have an API with a callback hook. So it's an API method where the custody sends the callbacks, alerting this application that some user deposited funds. And if this API endpoint is not sufficiently protected, you could spoof those requests and trick this app into thinking that you actually deposited the funds. Yeah, so that wraps it up. The next point is client apps, which is the mobile wallets, the front ends, the desktop apps such as Electron apps. So we have, my co-founder Arseny has a couple GitHub repositories that you can check out. They have some neat proofs of concept, for example, even evil NFT. And you can use them to try to find cross-site scripting vulnerabilities in the Web3 front ends. Actually, not long ago, Etherscan had this cross-site scripting vulnerability when displaying an ENS name on the Explorer page. It was fixed like a month ago, I think. So apart from the normal web front-end attacks, there are also, of course, there are desktop apps. Often they are written in Electron, and Electron has this nice capability of executing shell commands from within it. So if you have a way to control the code which is executed inside the Electron page, then possibly you can have code execution there, shell code execution. Let's jump further. So the infrastructure attacks, there are some very interesting attacks related to the RPC key abuse. For example, if an app uses RPC key on the server side and there is the same key on client side, it's trivial to abuse it, to rate limit it, and so the server side will stop working, and then there are some unexpected consequences. The same way you can cause the denials of service of any third-party dependency, any API, which is crucial to the operation of the service, such as defile lemma, for example. If it goes down, then many other apps also will become dysfunctional. And of course, there are BGP hijacking and other network attacks. And another interesting thing is that many people don't know, IPFS. There is Cloudflare IPFS endpoint, which has a single domain name for every IPFS page on it. So each resource is only a subfolder on this host. So if there are two different IPFS frontends on the same Cloudflare endpoints, they share the origin, and they can read the local storages of each other, which is a huge bug, huge hole in the web security. So as for the backends, there's more or less the same as in any Web2 application, and you should pay attention to the fields that the smart contracts have, the new insertion points for injections, for example. So the ERC20 symbol or description can be inserted somewhere in the Web2 application, and you control this field. So there might be some vulnerabilities there, as well as in NFT metadata processing. So that's it. I was trying to squeeze as much information here as possible. I hope you got something from it. And if you have any questions, feel free to reach me out.